Gibbs energy change and equilibrium. So we discussed spontaneity in the case of irreversible process. Now what happens in reversible process? And in a reversible process the system is in equilibrium with the surroundings. Now let us take a reversible reaction. A plus B gives C plus D. In this reaction, the reaction is in equilibrium means the reaction takes place in both forward and backward reaction, and the reaction is in a chemical equilibrium. Okay, so the reaction takes place simultaneously in both direction. Okay, so this means that if a reaction takes place, there will be decrease in free energy. So in both direction there will be decrease in free energy, but it is impossible. So it is only possible that at equilibrium the free energy of the system is minimum. That is delta G of R will be equal to 0. Okay, this is at equilibrium. Okay, now this free energy is related to equilibrium constant. There is an equation called 1/2 reaction isotherm, that is delta G of R will be equal to delta G in the standard state plus RT ln K. K is the equilibrium constant, delta G at standard state. R constant, T temperature. This equation is known as 1/2 reaction isotherm. Okay. This equation. Okay. Now we know at equilibrium this is equal to 0. So like this plus RT ln K. Or we can write delta G R at standard state will be equal to minus RT ln K, or this is equal to minus 2.303 RT log K. This is the equation. Okay. So we know delta G standard equals minus RT ln K, also is equal to delta X standard minus T delta S standard. Okay. Now, if it is an endothermic reaction, in an endothermic reaction, we know delta H is large and positive. It's a positive value. Okay, so what happens to delta G of R? Delta G of R minus RT ln K is large. Okay, so K is small or K is less than 1. Okay, and we know K is the ratio of concentration of products and concentration of reactants. Okay, so if K is less means less product is obtained in this case. Now, in the case of an exothermic reaction, in an exothermic reaction, we know delta H is large and negative value and negative. Okay, it is large and negative. So delta G is having a large negative value. Okay, the value is negative value is large. That means K is large or K is greater than 1. So greater than 1 means it is almost go for completion. This is the case in the case of exothermic reaction. Also, this delta G, the reaction, this free energy also depends upon delta S also. Whether it is large or small, this delta G also depends upon delta S also. Okay. So, from this we can conclude certain important points about Gibbs energy change. First point, if delta G is known, we can predict the spontaneity. predict spontaneity. That is, we already discussed, if delta G is 0, it is at equilibrium. If delta G is negative, that means it is spontaneous, and if it is positive, it is non-spontaneous. Next point, delta G is useful work, that is delta G is equal to minus W. So, delta G is useful work done. Okay. Now, third point, we can also calculate delta G, that is delta G. If delta H and delta S are known, we can find delta G. If delta G is calculated, we can easily calculate equilibrium constant K from delta G. Okay. Another important point. Next, if K is calculated directly from the lab, we can find delta G at any other temperature. Okay. So, if we calculate K from the lab, delta G at any temperature can be calculated. Okay. These are the important points about Gibbs energy change.